Maliit man o malaki ang isang food processing operation, gumagamit ito ng samut-saring food contact surfaces sa operation. Dahil dito, kailangan nating alamin ang mga mahalagang karakteristik ng food contact surfaces. Pero ano nga ba ang mga food contact surfaces? Lahat ng bagay na nilalapatan ng raw, in-process or finished products during the production hanggang sa packaging ay kasama sa food contact surfaces. Usually gawa ito sa stainless steel or plastic, pero meron din mga pagkakataon na ito ay gawa sa kahoy, rubber, or ceramic materials. Mula pa nung sinaunang panahon na natuto mag-process ng food ang mga tao ay gumagamit na sila unknowingly ng food contact surfaces. Whether this be animal skin, yung mga lalagyan na shells or even coconuts, no? Mga bato, baskets, pots, ceramics, mga simple woven sacks, meron ding mga glass container and even the wooden barrels or wooden chopping blocks, wooden surfaces. And lately, of course, we have even paper, plastic, and metals. So, syempre, over time, habang nag improve yung ating kaalaman sa hygiene, ay nag-improve din yung standards natin sa kung ano ang pwede gamitin na food contact surface. So, the ideal attributes is that it's non-toxic and non-contaminating. So, for this reason, no, merong mga materials dati na dahil nagre-react, let's say, yung pewter plates with the acids in tomato causing sort of a food poisoning, then pewter plates are no longer used as food contact surfaces. Okay, so they must be resistant to food acids, and of course, depending on the temperature at which the processing is happening, there should be no migration of the material to the food, or vice versa. It should be, of course, easy to clean, durable, maintenance-free, resistant to corrosion with acids and other strong substances in food. Of course, smooth, impervious, and free of cracks and crevices, non-porous and non-absorbent, so most woods would not be ideal in this case. And I would like to add that it should be detectable, as is the case with, in production where they have metal detectors. That's why most of the um, food contact surfaces that are found in food are those that are not metal, like let's say glass on your cereals and so on. So nowadays, metal is one of the most preferred common food contact surfaces, although there are still a lot of plastics like in conveyor belts. Most of the gaskets are still rubber or rubber-like materials. There are cases wherein we still use ceramic and glass, such as when you have a viewing window along a pipe, or in certain cases, whether it be packaging or just the thing where the surface where the food are put, you still have paper and wood in some cases. However, for wood, it's ideal that you use the types of wood that don't have very large grains or are not as porous. Many different metals now are used for food contact surfaces, but stainless steel is the most preferred, especially in GMP compliant, HACCP compliant food manufacturing facilities. Titanium is used for its durability and corrosion resistance, but these are limited to high salt and high acid foods because of their expensive nature. Same with platinum. And gold is sometimes used as a soldering material, especially for optical sensors that come into contact with food in stainless steel fittings. Traditionally, they used copper in Swiss cheese manufacturing. However, because it leaches into the product, then it's usually not used as a direct contact material anymore. And although aluminum is lightweight and corrosion resistant, it's not as durable, and usually it's plastic coated when used for food contact, especially as a packaging material. We also have carbonized metal or cast iron, which is still used mainly in food service, and galvanized iron is already avoided, especially as it is reactive with acids. Focus tayo sa stainless steel because it's the most common. Ano nga ba ang stainless steel? Okay, it's not simply iron because you know that iron rusts, and stainless steel is called stainless because it doesn't rust. And that's because, among other things, it's a combination of different materials. It has copper, chromium, molybdenum, manganese, nickel, phosphorus, nitrogen, selenium, tungsten, and or titanium. But generally, most stainless steel would have just at least 4 of these materials together. There are more than 150 grades of stainless steel, but we need to take note of those that are food grade, mainly the 304 and 316 grades. From your food physics, for some of you, you can maybe remember that there are austenitic and ferritic and martensitic materials in terms of metal. So these are also the categories for stainless steel. For most food types, the stainless steel type used is a combination of iron, carbon, chromium, and nickel, and iron, carbon, chromium. So here's just a brief rundown no, ng mga silbi ng mga elements na ito sa stainless steel. So chromium is primarily for corrosion resistance. Nickel does the same but also improves strength and structural hardness. And though it increases the chance of corrosion cracking due to stress. Carbon is there to add strength and structural hardness and resistance to oxidation. But too high concentrations increase risk of corrosion, so you need to strike a balance. Molybdenum, on the other hand, strengthens the passivation layer, which is something that prevents pitting corrosion, especially when you are dealing with repeated cleaning with acids or using acidic foods. On the other hand, there's also phosphorus, sulfur, and selenium for machinability, mean to say when you're creating stainless steel shapes and of different sizes and shapes. And you also have titanium for increased strength, durability, and heat resistance and corrosion resistance. However, of course, adding more titanium increases the expense of that type of stainless steel. So not all types of stainless steels are the same, and although there are many types that we could see here, we would want to focus on 304 and 316. Which are the main ones used for food applications, although these other variants in the 300 series may also be used, but they are less common. So again, looking at 304 and 316, as you can see here, their main difference is that 316 has additional molybdenum. And because of that, of course, there are some variations in their chromium, nickel, and molybdenum concentrations. But generally, the base is that carbon and manganese are as follows. And to make up the difference is, of course, the rest is iron. So maraming dahilan kung bakit maaring magkaroon ng stainless steel. Ang mahalaga ay alam natin kung saan nanggagaling ito at kung paano ito mapaprevent. No? So maaring dahil lang sa continued exposure or acute exposure, lalo na sa clean-in-place systems, we use acid and alkali solutions, or pwede ring exposure to things such as very high temperature, low pH, and certain agents, or maybe improper equipment design. So ito pa yung iba, no? Pwede ring galvanic siya or physical contact with carbon particles. Depende sa cleaning and disinfection mo. Pwedeng biological yung nature niya or exposure to extreme conditions or agents. So mahalaga lang dito, iniingatan natin yung stainless steel natin sa paggamit at sa paglinis, and we make sure that we supply them from reputable manufacturers. Here are magnified examples lang of corrosion and pitting types of chemical and pitting types of corrosion. And then from a side view, ganito naman yung itsura ng mga pits, no? So kahit maliit lang yan, the effect on the structural ng ating surface, of course, is malaki, lalo na pag nagkaroon ka ng pits, pwede rin, of course, na mag-harbor yan ng microorganisms or mas dumikit siya kasi hindi na smooth yung surface. To briefly mention passivation, which is the using of nitric acid or other oxidizing agents to form a passive or non-reactive layer of oxide film on the surface of the metal. So it's used initially, tinatawag na passivation bago sa unang gamit sa food processing. And in maintenance, parang ma-renew yung passivation layer. And of course, when you did some surface repair. So as you can see here, what it does is form a layer that hides the damage, or forms a layer over the damage, and it reforms automatically so that you protect the steel underneath. So yung mga rubber materials, hindi natin sila may iwasan, no? And ideally lang, it's food grade. Sometimes they're single use, but most of the time they're multi-use. And again, usually mga gasket sila. Pwede ring container or sa conveyor belts mo, O-rings, and sometimes there are rubber components in the packaging material. Ceramics are used mainly in membrane filtration systems, and sometimes the use of ceramic knife blades or blades in the equipment. Glass has limited use. It's usually just as sight glasses and openings. However, these must be heat resistant, durable, and you must be able to monitor their condition every time so that you know when there are cracks or when some of the glass has fallen off the equipment. As much as possible in modern times, you want to avoid the use of wood as a food contact surface because of its high porosity and difficulty to clean. However, in food service, sometimes it's still used as cutting boards and butcher blocks, in which case we use hardwood and those with tight grain varieties. Rather than as packaging material, paper is usually used as single-use gaskets for equipment with daily disassembly, such as this one figured in here. Sanitary design principles, okay, this is how you construct your equipment and food contact surfaces. They must be of a certain smooth finish as much as possible, and then in the construction fabrication of tanks, pipes, and the likes, you need to consider the internal angles, the joints, and any other connections, openings, and covers, where they are installed, how they are installed, and the non-product contact surfaces as well, which are also part of the equipment, such as the external part of the equipment. So for surface texture, they must be smooth, durable, and free from cracks. If it's stainless steel, there's a certain level of polishing called the number 4. Or if it's an unpolished surface, there's the 2B or mill finish. This is represented by a roughness value, which can be calculated using a diamond-tipped stylus that measures peaks and valleys in the surface. So here are the samples for the types of finish by numbers, called the mill and polished finishes with their descriptions. You can Google more about this if you want to. General requirements for construction and fabrication: there should be no sharp corners, dapat rounded. The joints should be continuous or flush. So dapat same diameter sila. Parang ganyan, may flanges. Madaling i-disassemble, and tanks should be self-draining, no? Walang chance na mag-pool yung water inside for sanitary purposes. So here are other samples for acceptable and unacceptable. If you're going to reduce, it has to be eccentric, meaning to say tapered siya, flat yung bottom, okay, and smooth. So side view pala to, by the way. Okay, of course, it's always angled downward to prevent the pooling of water on certain areas. Corners should be rounded, and there is defined radius for this, and internal angle should be less than 135, and physically it should have a minimum radii of 6.35 millimeters. Again, this is for easy cleaning and the prevention of microbial or buildup of whatever food ingredient could stick there, making it harder to clean. In terms of welded joints, these should be smooth and sanitary. So we cannot use lap welds, yung parang magkapatong. Ito butt welds, pinagdikit lang sila, and then ito po yung welding point niya. Okay, so these are side views, top views, 3/4. And then the joints should be finished as well. So hindi pwede yung winelding mo lang tapos na. So kailangan smooth na siya, tapos parang aanahin pa yun, ipapolish mo pa yan. Okay. And the materials used for soldering should not be toxic, obviously. And we limit the press and shrink fits if and when welded joints are not possible. During construction, we also consider if there are any dead spaces, we want to remove them because basta walang lugar kung saan pwede mag-accumulate yung food product, whether liquid or solid. And pag nilinis mo, malilinis siya thoroughly kasi kung hindi, pwedeng mag-harbor mag-grow ng microorganisms dyan over time. And if you have shafts and bearings, they should be sealed to prevent contamination of lubricants getting into the food. Although there are food grade lubricants, but of course prevention is much better. For other joints, when coupling pipes, it should be close coupled, or the pipe connection length should be less than the pipe diameter. When it comes to openings and covers and the top rims, we want to make sure that there is adequate protection from outside contamination and diverts potential contamination away from the food products and not towards it. So if there's anything that could drip, then the design should be made in such a way that there's no way that whatever is dripping could get inside. We could also use lift opening like with the shoebox, okay, so that as you can see here, there is a downward lip that goes with it. So you probably haven't seen this since FS127, pero at least yung top rim design, no? So, dapat hindi siya mag-collect ng dust, hindi siya squared, walang potential for ingress. So either lip siya pero open pababa, or fully closed yung cross-section niya. And in GMP equipment design, we want to make sure that there are no possible sources of pathogen or insect rodent infestation. So you should construct with appropriate materials that are easy to clean, corrosion resistant. If they're using tubular frames, they should be sealed because these tubes could harbor insects inside. You might have ants or cockroaches there. Then there should be seals so that there's no possibility of penetration. For example, if you drill the screw hole through here, and as much as possible, you would want to weld the attachments rather than drilling them. Because when you drill, you create an opening to get inside. But when you weld something, then it just sticks surface to surface. So avoid areas for dust accumulation. You have to downward sloping yung mga tops of equipments, parang mga bubong, no? Para hindi mag-accumulate yung dust and water and whatnot. Legs should be sealed at the base, and even the threads for leveling, like these ones, should be enclosed to avoid insect contamination. Okay, so there should be a logical sequence to avoid cross-contamination, yung pagkakasunod-sunod ng equipment mo, nakasang-ayon yan sa process mo, and then there should either be adequate space from the wall, 4 inches, or from the floor, 6 inches, to allow cleaning. Of course, if the equipment is larger, you would need a larger floor clearance kasi baka kailangan sumuot ng tao doon or something. And then there should be, you can also have it sealed to the wall or to the floor, dikit siya na walang gaps. Okay. And there should be no any area para magtago yung mga daga mo at saka mga ipis. So for the trends, there are essential oils now being used as food contact surface sanitation, such as this Mediterranean wild thyme essential oil extract. So there are now different types of electrochemical biosensors that can be used to rapidly assess, quantify the, let's say, coliforms or other microorganisms in your food contact surface. There's also the food contact surface treatment, such as in modification of aluminum with superhydrophobic coatings, which reduce the attachment of microorganisms and even dirt and mud. As far as the use of ultraviolet light goes, these have been applied to food contact surface for bacterial load reduction and Salmonella, specifically Salmonella population reduction. As far as studies go, there have been studies implicating that human norovirus can be recovered from food contact surfaces even up to almost a month after inoculation, and these have been identified through the use of RT-PCR. Here are the references if you wish to know more about the things we discussed today. The major ones are, of course, from Schmidt, and these are available online.